Okay, let's look at problem number 2 from the review packet, free response review packet. So a couple of things before you watch this video. This is the second time we are looking at a problem where they give us a graph and we're supposed to answer questions regarding that graph. Because it is the second time, you should be trying it on your own before watching this video. That's important. Okay, don't watch this video unless you've already given this a try. Okay, so if you haven't given this a try, stop the video right now, go through the problem, do your best. Look at the first one. So I do want to remind you, there's already one video. It's the first video in this playlist. So it's problem number 1. If you need to, go watch it again. Okay, then attempt this problem. Once you've done that, then come back to here, okay? Because I'm not going to do as much of explaining in this one. This one's going to be a bit faster. Okay, that being said, hopefully at this point, if you are still watching, you have done this problem. So let's go through this. Let's see what we are given. So we are given this graph that contains, semicircle and some line segments. That's fine. By the way, you'll notice, I know it may be hard to tell, but my graph may look slightly different than yours. So do refer, if there's a, make sure you're kind of referring to your graph if mine's slightly off. Then we are told that g of x, right? So we have this g of x function equals the definite integral of here. So of f of this function right here. Okay? So just be aware of what that represents. So we are then given a graph, and we've talked about this before. It's really important. If they give you a table, a graph, an equation, whatever, you need to decide, you need to determine right off the bat, are we looking at a position function, a velocity function, or acceleration function? In other words, in this case, right, we're looking at a derivative. We are looking at the derivative of g of x, right? Because, and just to be clear, if I take the derivative of g of x, right, by the second fundamental theorem of calculus, what I get is, whoops, I don't need that d of x. I don't know what I'm doing there. I get f of x. Okay, so in other words, this graph right here is the derivative of g of x. That's important, okay? Because what does that mean? So by definition, if I want to go find some values for g, right? If I want to go find like what is g of 7, then all I need to do according to this is plug in 7 into this function and evaluate, find that displacement based on the way they are defined this. If I want to find g of 2, I plug in 2 here and find the area underneath, that curve from, -3 to 2, boom, that's my value. On the other hand, if they are asking me derivative questions, right? Like if they want to know what is g prime of 3, well, g prime of 3 equals f of 3. So I look at this graph, I go find 3, and I say f of 3 in this case is 1, 2, 3, is 0. Okay, so again, it's important that when you are looking at this graph, you know how it relates to your given function. That being said, let's get this going. So let's go find g of 0. So g of 0, g of 0, let's try that again, not go. G of 0 is going to be equal to the definite integral from -3 to 0 of f of t dt. So again, think about what that is. This is the displacement. It is the displacement for the graph of f from -3 to 0. So let's see, where does -3, 2, 3. So we are looking, I'm going to highlight this in like a light orange here. So we are looking at this section right here, okay? And it's asking us to find the displacement or the area underneath the curve from -3 to 0. So this is a geometry problem from here on out, right? You have to find the area of that orange rectangle, or that orange trapezoid. Since the orange trapezoid is above the x-axis, it's going to be positive. So I'm going to get, now I'm going to just use I'm going to use the area of a trapezoid. So the area of a trapezoid is 1/2 the average of the bases. So this is, I'll call this base 1 and I'll call this base 2. So base 1 is a height of, looks like 2. Base 1 is a height of 1. And then it's multiplied by the height. So this is kind of like a trapezoid on its side, right? The height is 3 units. And that is our answer. Again, we could clean that up if we want to, but you are more than welcome to leave it like that. Let's see, I'll clean it up. 3 plus 3 is 9, 9/2. Okay, let's answer the second question. So first question asked us about G, And again, in order to do that, right, we use the fact that if I want to find g of 0, I evaluate this definite integral from -3 to 0. So I'm finding the area underneath the curve because, again, this is the derivative of this. Now, what are they asking us to find? They are asking us to find g prime, I lost it, g prime of 0, right? Which, again, if we go to here, right? So let's just kind of spell this out. When I take g prime of x, I get f of x. So if I want to find g prime of 0, let's move that up a little bit, shall we? That's going to be equal to f of 0. So what is f of 0? So f of 0, this is 0. F of 0 is the height of the function at 0. So f of 0 is 1. So g prime of 0 equals f of 0, which equals 1. Okay, let's move on. So for next question, I don't know why this is here. Find all the values on the open interval from -5 to 4 at which g, so the function g, attains a relative maximum. Okay, so think about if I gave you a function and I said, okay, I want you to go find where this thing has a maximum. Let's think about the things that you would do. One of the things you would do is you'd say, okay, in order to find where g has a maximum, I'm going to take the derivative of the function. We know the derivative of that function equals this, okay? So first thing I'm going to do is I'm going to take the derivative of the function. Next, second thing, right? I just want to check one thing. Nothing. Okay, second thing, I'd go and find the critical numbers. Where do critical numbers occur? Critical numbers occur where the derivative equals 0 or the derivative is undefined. Right now, they don't give us any values where the derivative is undefined. They would need to kind of tell us that, or they at least need to give us like a vertical asymptote or something like that. We don't have that, so in this case, I really want to know where does g prime of x equals 0, and that's going to occur. I think you guys would agree where f of x equals 0, right? Because g prime of x equals f of x, and I want to know where does g prime of x equals 0. That means I want to know where does f of x equals 0. So where does f of x equal 0? Well, I think you guys would agree. It equals 0 here, it equals 0 here, and it equals 0 there. Okay, we have found the critical numbers, right? If we want to list them, we can. What are our critical numbers here? Our critical numbers are x equals -1, 2, 3, 4, +1, and is that 1, 2, 3, 3. So these are our critical numbers. Now, what do we then do? So normally, again, if you were given this in class in a graphing, right? If I asked you to, if I gave you a function, I said to graph it, you'd make a sign chart. Let's do it. Let's go make a sign chart. So here we go. And we're going to put our critical values in there. And then what do we do with our sign chart? Well, we look to the left and right of each critical value and we say, we are looking, is it negative? Is it positive? What's going on there, right? So let's go to -4. I'm going to look to the left, right? I'm going to look to this direction. And I want to know, is my derivative positive or negative to the left? Well, because it lies below the x-axis, the derivative is negative, right? And you can kind of test it. If you're like, whoa, that doesn't make any quite sense, think about this point right here. What is this point? Well, this point is the point, what is it, -4. Is it -4? 1, 2, 3, 4. No, -5, excuse me. It is the point -5, and this is the important point, -2. This -2 is any point, right, from here to here. If you look at the y-coordinate of each of these points, they're negative. And of course, the y-coordinate is the derivative value, right? So from -5, I meant to point, from -5 to -4, because the graph is below the x-axis, our derivative is negative. Okay, what about to the right of -4? Why don't you right now figure that out if you haven't? If you were like confused on that, do that now. Okay, so let's see now. So now I'm looking at this portion of the graph, right? This is all to the right. And because our next critical value doesn't get to here, I think you'd agree it lies above the x-axis. So, boom. It's got to be positive. Okay, now let's go to 1. Let's look to the right of 1. Again, it's still above the x-axis. Plus. A plus sign, it's positive. And then, finally, we're at 3. We're at 3, we're going to look to the right of 3. I think you'd agree this graph is below the x-axis. So our derivative values are negative. So what does this tell us? Well, I think you guys would agree. This tells us that there has to be a minimum at x equals -3. There is a stall, right? Looks like there's some sort of stall at 1. And then there is a maximum, a relative maximum at x equals 3. So what's going to be my answer here? Now, notice they asked us to justify it. You cannot justify using a sign chart. Okay, while this was really useful to me, right? While this was really useful to me, it's not a justification. So here's what I'm going to say for my justification. First off, I'm going to state my answer. So I'm going to say when x equals, what was the value? 3. When x equals 3, there is a relative maximum. Now, how did we know that? And you can't just say, right? You can't just say, well, I looked at my sign chart. No. What was it about the sign chart that you looked at specifically, right? What you specifically looked at is you looked at the fact that to the left of 3, the derivative was positive, and to the right of 3, the derivative was negative. So I will say, let's see. So when I want to put this into like something that makes sense. When x equals 3, there is a relative maximum because, I won't put a period there, because g prime of x, which equals f of x. Again, I want to point, I call this pointing. I'm saying, hey, I'm getting information about g. How am I doing that? I'm looking at f of x. Okay, so I'm kind of pointing here. So I'm saying, look, g prime of x, so there's a relative maximum because g prime of x, which equals f of x, changes from positive to negative at that x value. Again, the key here is I'm telling them how I figured out. I tell them I'm looking at this and I'm telling them how does this relate to my graph of g? Oh, it's the derivative of g. Let's move right along to letter C. Okay, so letter C wants us to find the absolute minimum on the closed interval, and we want to justify our answer. So notice how there's so many flashcards here. So I'm just kind of like time out for a second. Let's just talk about this real quick. Notice there's a lot of flashcards going on here. So for example, just pointing out, recognizing that the derivative of this was equal to this, that's the second fundamental theorem of calculus, flashcard. Knowing how to find a relative minimum, relative maximum, right? Flashcard. Okay? In this one, knowing how to find the absolute minimum, that's a flashcard. So what is the flashcard for that one? Well, relative extrema, absolute minimums, not relative, absolute extrema. So I keep on saying the word relative. Absolute extrema. So absolute maximums or absolute minimums occur either at critical numbers or endpoints. So in other words, for this graph, the absolute maximum or minimum, right? In this case, I'm looking for a minimum, but the absolute extrema are going to occur either here or somewhere in here at our critical values, right? So let's see what we got. So I'm going to kind of go back here really quickly, and I'm going to go and grab this so we can kind of talk. So I'm grabbing this sign chart again because this was pretty useful. Again, they don't look at the sign chart, but it is useful to us. And the reason being, right? The reason being is, one, we know our critical values. So we know that we have critical values at -4, 1, and 3. Now, do we need to look at all the critical values? No, we don't. The only critical value we really need to look at is this one, right? -4. That's the only possible one that could be a minimum, right? This is a stall. This is a maximum. So I really need to look at 3 points. I need to know, one, let's do our critical value. I need to know what is g of negative 4. 2, I need to know what is, g of negative 5, our left-hand endpoint. And then finally, I need to know, I'm going to move this down a little bit. I think I need room. And then finally, I need to know what is g of 4. Okay? Because we're looking for absolute maximum, when I go and evaluate these, whichever one of these gives me the biggest number, right, the largest number, that's going to be my maximum. So let's go and do that. Let's go figure out what each of these are. So g of negative 4. So g of negative 4, where is g of negative 4? G of negative 4 looks like it is 1, 2, 3, 4. So it's this entire piece right there, right? So actually, if you wanted to, well, actually, let's show that. So how do we find g of negative 4? G of negative 4 is from negative 3. Actually, it's not that. I'm sorry. I messed up. I'm glad I put this in. G of negative 3 is, right, because I'm basing it on this. This is what I need to be looking at. It goes from negative 3 to negative 4 of f of x dx, right? So again, all I did in order to find g of negative 4 is I plugged negative 4 in. So I plugged negative 4 in here. So what is that? Specifically in this case, I think you guys would agree, it's just this triangle right here. Okay, now, before we evaluate, let's be careful. My limits of integration are currently going from larger to smaller. I don't want that. So I'm going to flip my limits of integration. Don't forget, you make it negative. So we get negative 4 to negative 3 of f of x dx. Now, what do we get? So now let's plug it in. So it's negative. And what is the area of that triangle? I think you guys would agree. It's 1/2 the base, which is 1, times the height, which is 2. I'm going to clean this up just a little bit just in case I need it. So this is 2 times negative 1/2. That is negative 1. Actually, I'm just going to keep an eye on. We were trying to find an absolute minimum value. Okay. Let's go and find g of negative 5. So g of negative 5, I think you guys would agree. Similar idea. Goes from negative 3 to negative 5 of f of x dx. So what does that equal? Well, first off, let's flip those limits of integration. We want them to go from least to greatest, not greatest to least. So negative 5 to negative 3 of f of x dx. So what are we looking at in this case? So we are looking at, we're starting from here. Remember, it's always the area from the curve to the x-axis. So we're looking at this, and we're going all the way to 1, 2, 3, to this, right? So I think you guys would agree. I think you would be okay. Just to be clear, I think you guys would agree. This one's negative, this one's positive. They're both the same. I think you just saying 0 would be fine. I don't think you have to justify it. If you're worried about it, you are more than welcome to say, okay, that left one is negative 1/2. The base is 1. The height is 2. I just want to make sure it's negative. So this one's negative. And then I'm going to say plus the other one, which is positive 1/2, 1 times 2, which equals 0, or, leave it as is. Again, I do think this would be fine right here. I do not think you need to show this. But like I said, if you're uncomfortable with that, you're feeling like, no, I really feel more comfortable if I show how I got there, that's fine. Okay? I don't grade this, so I'm a little, I feel I'm pretty confident they would accept this. Okay, let's keep on going here. Then we have to find g of 4. I'm going to get rid of those. So what is g of 4? G of 4 is going to be equal to the definite integral from negative 3 to 4 of f of x dx. So I think you'd agree it's going to be quite a bit. It's going to be this piece, right? Which, by the way, we already found that. That was 9/2. I'm just going to put a little note there. So this was 9/2 plus, what are we going to? Oh, we're going to the endpoint. So plus all this. Okay? So let's see what we got here. So for this one, let's go and find it. So we got the area of that trapezoid. I'm just going to put that number in. We already found that number. If, again, we could say if we wanted to, if you wanted to be really like, hey, I'm showing you exactly what we do, is you could, if you wanted to, break this up into a bunch of things. You could say, okay, this is the definite integral from -3 to 0 of f of x dx plus the definite integral from 0 to, what does it look like, 2, of f of x dx plus, because that's what I'm doing, right? From 2 to, it looks like 4 of f of x dx. You're more than welcome to do that, but I do want to emphasize, I think that's going a bit much. I don't think they need to see that, right? I would, if you, I know they don't need to see that. So what I'm going to do instead, again, this is fine, and you are more than welcome to be a little bit more explicit if you feel like you need to, but I don't think you need to. So what I'm going to do instead is I'm going to start doing my thing. So I've got this first one, just so you can kind of follow along with me. I'm going to take this first one because I already found it. So that is 9/2. I'm going to add it to this second one. So we've done this before. I'm going to find the area of the rectangle and subtract the semicircle. So the area of the rectangle looks like it's a 2 by 1. So it's 2 by 1 minus the area of the semicircle, which is 1/2 pi, is R1? Yeah, 1 squared. Okay, that gives me, so just so we know where we're at here, I'm all the way to here. And so the last thing I need to add is these two triangles. They're equal to each other, so that's 0. So I think you'd agree. I don't know what this number is, but it's clearly positive, right? This is 4.5 plus 3 minus this kind of small number. So this is a positive number. And they are asking specifically, what is my minimum value? So my minimum value is, now I do have to make this conclusion. My minimum value is, so I'll say there's a minimum. Sorry, an absolute, because they are asking for absolute minimum. Did I spell that right? Absolute minimum at x equals -4, which, let's rephrase that, because they're not asking for the x value, they're asking for the absolute minimum. So I'm going to say the absolute minimum is at g of -4, which equals -1. Okay? So let's talk about the justification. This is fine, right? When they're going through and they're asking for the justification, what they're really asking is, again, a reminder, they want to know how you did it. So what they're looking for in your justification is, 1, did you evaluate your critical number? Oh, you did, great. Did you look at your endpoints? Oh, you did, great. Did you make a conclusion? Oh, you did, great. This is your justification. All this math that I did right here, that's my justification. I don't need to say anything more. Let's move on to letter D. Okay, what do we got here? Find all the values of x in the open interval from -5 to 4 on which the graph has an inflection point. So, inflection point, right? Now we want to know, so inflection points. Inflection points occur, so if we have g of x, we have to take the second derivative, right? We want to know where the second derivative, where it changes concavity, right? So when does that occur? Well, the second derivative equals the first derivative of f of x. So I want to know, when does the first derivative change? Change. Now, I want to be careful here in terms of the words I'm using here. So now what I'm looking for, when I'm looking at this graph and I'm talking about second derivative, I'm looking at the slopes of the tangent lines to this graph, right? Because the slopes of these tangent lines are the second derivative. So now what I'm going to be doing is I'm going to be looking at, when does this graph right here, when does it change from increasing, right, where it has a slope that's positive, to a slope that's negative, so decreasing. Now I'm going to be using the words increasing, decreasing, because they imply that I'm taking a derivative of f prime. Okay, so I'm not going to say it goes from positive to negative, because positive to negative, right? When I'm talking about positive, I'm talking about f. oh, the F is positive here, F is negative here, right? We did that already. But now I want to talk about the slopes of the tangent line. So I'm going to use the words increasing and decreasing. So I think you guys would agree, right? Increasing, increasing, increasing. Right here, decreasing, decreasing, decreasing. So there must be an inflection point here. Where else must there be an inflection point? Well, there must be, so let's see. Decreasing, 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 decreasing. So there must be an inflection point here. Sorry, let me repeat that. Decreasing, 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 increasing, 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 right? So there has to be an inflection point here because it changed from decreasing to increasing. And then finally increasing, increasing, decreasing, decreasing. So there has to be an inflection point here. So my answer would be, now this one doesn't ask for justification, which is kind of weird. I kind of feel like they do, so I'm going to, or they should. So I am going to put a justification here, but they didn't ask for it, so you would not get taken off. All you would have to say is inflection points, or let's say, or I'll say inflection points, that's fine. Occur, I can't spell occur at x equals, what is it? Looks like it's -3, 1, is that 2? Yeah, -3, 1, and 2. That's fine. Okay, now, just a side note, let's go a little bit deeper. I know they didn't ask for this. And again, if they don't ask you to justify, don't justify. Don't get, one, why spend the extra time? You don't want to do that. But two, don't give them, don't give extra. There's no reason to give extra. But that being said, let's pretend for a second that they had asked to justify. Here's what I would say. So I would say there are inflection points at x equals, let's see, I'm gonna start with these two at x equals -3 and 2 because g double prime of x, which equals f prime of x, right? I'm pointing to what I'm looking at, changes from increasing to decreasing at those values and, right, and there is an inflection point at, what is it? It looks like it's x equals 1 at, that's not even an at, that's an ax, at x equals 1 because, I'll point again, you probably don't need to, that's getting kind of, being a bit repetitive. G double prime of x, which equals f prime of x, changes from decreasing to increasing at that x value. Okay? Again, they didn't ask for that. We don't need to give it, but it's a pretty common thing for them to actually ask you to justify it. This would be the justification. I will tell you, I would suggest, and I don't know if it's a big deal, this is just kind of thinking about this from the point of view of the graders. They're going pretty fast. I would, if they ask you to justify it, okay? If they ask you to justify it, I would have my summary right here. I'd quickly just go and say this, and then I'd give my explanation. And the only reason is you kind of want to make sure that they see that you mention all three values. Again, remember, they are grading a lot of these pretty quickly. You don't want to lose points because they missed something. Yeah, it's their fault and they shouldn't. Just be safe. Okay? Anyway, that is problem number 2, and I will see you in the next video.